Hello everyone and welcome to Terabyte. We are Geek Gurus Union and this is our fourth and final demo video. Meet Terabyte. Terabyte is a data-driven crop prediction system that analyzes crop yield, weather data and soil data to predict yield and health. This helps farmers to enhance food security and optimize resource management in the face of changing climate conditions. So for our user stories, we have identified three. The first one is a farm manager. The farm manager wants to see detailed reports on predicted crop yields, health and sprayability so he can effectively plan resources and operations well. He also wants the ability to manually update data if it is necessary and manage his team's access to the system. Our second use case or user story is a farmer. So as a farmer, I want to enter my farm's data into the system so that I can get an accurate crop yield prediction. I also want the system to handle any missing or incomplete data that I am unable to collect. And our final user story is for a data analyst. The data analyst wants to access detailed reports, export data, and analyze field and revenue information. This will be done by using various dashboards so it can provide him with actionable insights based on the farm's performance. Okay, so for our live demo, we'll run you through the core functionality of the app. The app can be accessed through our landing page. This can be done by following the link terabyte.software. You can scroll a bit down and view the features of the app and the highlights of our product. Clicking on the Access App button takes you to the application. You'll be prompted to log in, or you can either log in via email address and password or your Google account. If you do not have an account, you can just follow the sign up link and sign up through there. For this, let's use my Google account. And there we go. So as we can see, this is the homepage of Terabyte. This is the field dashboard showing you a lot of actionable insights on your fields. The app is prompting me to select a field, so let's go ahead and choose one. As we can see, it specifies the crop type and the hectare of the field. It shows a little AI weather summary, the predicted yield for today, and the health of today. There's also a sprayability factor and a precipitation forecast for today. And if we scroll a bit down, we can view more stats. As we can see, there are a lot of graphs giving us more actionable insights and data on our field. It shows all of these and it can be filtered as well by 14 or 30 days. But first, how do you add a field? This can be done by going to the Add Field page. Okay, so adding a field will first ask you for your location. This will be used to track your current position or your location, allowing easier access to logging your field on the map. I will go ahead and allow. Firstly, let's enter the new field name. I would like another barley field and I select the barley crop type. As we can see, we've searched a place and I want to log a field here. You'll see polygons on the map representing already registered fields, and as the prompt above tells us to, we can click on the outer bounds of the new field and start drawing the new map interface. So once I'm done, I can go to the next step. It will give me a confirmation of UP barley. This is the field name, the crop type, and it also gives me a confirmation that my field map is drawn. To manage your fields, you can go to the sidebar and go to Manage Fields. You'll see an overview of all your fields where you can search for a field by its name. So let's say I want UP fields. I can also filter by a crop type, let's say maize, and then I can view or edit the field as well. This opens a dialog where I can enter the new name. Let's just change it the same, and change the crop type as well. Editing the map allows you to draw and adjust the polygon as well. And lastly, we have training. If you click on train all, this will schedule all your fields for training. And if you click on the train button on the field card, this will train its individual field. This will give you new predictions on your yield. Next, we'll go over to logs.
On the View Logs page, we've implemented a dynamic table displaying all the relevant data for your field. Users have the flexibility to export, print, and edit the data directly from this page. When you want to print a field, you select the Generate Field Report button in the top right-hand corner. It then prompts you and asks which field's data you want to print. You can then select the field and hit the print button to see your printed PDF report. For exporting data, you can select the fields you wish to export in the left side of the table and then hit the export button in the top right hand corner. This will generate a CSV report for you. And then finally, we also implemented editing data. Editing data is however restricted to users with appropriate permissions, thus ensuring data integrity and security. To edit a field, you select on the table on the cell you wish to edit. You then edit the value and hit enter to save the value. You will then be prompted with a successful message ensuring you have changed the data correctly.
To manage your team, you can go to the Manage Team page found in the sidebar. It gives you a table with all your team members, the email addresses, name, role, and actions. I can either remove a user by clicking on the trash icon if you have the appropriate role, or you can edit the role of a certain member as well. Inviting members is an easy task as well. You click on the invite member, add their email address, select their role, and send the invite. This will send them an email, and from there they can follow the instructions to open their account or join the team if they already have one. Next, we bring you to the Teams chat page. So as you can see, I have a Teams chat integration into the app. I can speak with my team members and ask them to water fields or any general info as well. So I can ask Tian to please update something on the logs. In the settings page, which can be found from the user icon and clicking on the settings, you can edit your full name and also change the color mode of the app itself. This will update your profile and update your preferences based in if you like dark mode or light mode. Switching dark or light mode can also be done in the navbar on the user icon and clicking on the toggle theme page. On the revenue dashboard, which can be found from the sidebar in the revenue dashboard link, you will see a dashboard which shows you your predicted revenue. This takes into account your combined hectare of all your specified crop type and the ton per hectare for that crop type. If you scroll a bit down, you will see a chart which is your predicted revenue. The bars represent your predicted revenue of your current predicted ton per hectare, and the line represents the past average predicted revenue. This is based on the average 5 years ton per hectare outputs of the crop type. Okay, and done. Lastly, if you need any help with the app, just click on the question circle on the navbar. This will take you to the help menu, which explains each and every functionality of the app itself. You can select a menu or a dashboard, and from here you can see descriptions of each and every component. Selecting a field in this case shows you how to work with a field card. It gives descriptions on each and everything, and it's interactive as well.
So since Demo 2, we experimented with a range of machine learning models. We critically investigated the model's performance throughout And now today we present to you Terabyte's Fusion model, a smart ensemble model based on XGBoost and statistical hypothesis testing. Pre-processing were one of the things we spend a lot of time on, reasoning about the data sets we use and more critically, how we align temporal data. We've also experimented with handling missing data by means of a KNN imputer, which efficiently made our dataset complete. We took notice of a rolling window approach, which takes the average from the past 5 days, for example, which might exploit long-term correlations between features and target variables. Unlike ETL, which processes data upfront, ELT allows for on-the-fly feature introduction and rejection, ensuring data flexibility and scalability. Additionally, ELT improves server performance by enabling daily weather fetching, making it a suitable choice for dynamic use cases. So why XGBoost? XGBoost, or in long, extreme gradient boosting, in itself forms part of the ensemble learning category, and more specifically, the gradient boosting aspect. Gradient boosting algorithms consist of multiple decision trees where each tree makes a prediction and finally, per definition, averages all the tree's predictions. The idea of gradient boosting as opposed to a random forest is to combine weak models into a single strong model, but also by following an iterative approach trying to improve on the preceding model. Regardless of claims in theory, throughout the hypothesis testing, XGBoost has proven to be a sufficient choice for predicting crop yield. So dividing our fusion model into 3 separate models, our first model is the stage model, which works by grouping data into the current states based on crop-based heuristics. The predictions are done to date, minimizing the possibility of a weak prediction at the start of a stage. The second model, the multiscale model, follows a similar approach, but just works on a calendar structure instead of using crop-based heuristics. In this model, we use 6 different frequencies, 5 daily, weekly, monthly, quarterly, and yearly, and they are all independently fitted on the same dataset. Finally, all 6 predictions are ensembled into one array. And lastly, our yield-only model predicts yields based on previous years of yield. The outcome of this predictions are merely used, but serves as an alternative hypothesis to prevent inconsistent predictions made by the other 2 models. To ensure consistency in predictions, the model has been fitted with a standard hypothesis test that forms part of a pipeline that either rejects or retains the predictions made by the respective models. So with hypothesis testing, we state that our null hypothesis is the predictions done by the multiscale model. With a 99% confidence, which turns out to be plus minus 1 within the mean, the hypothesis testing remains generous while ensuring consistency. I'll now hand over to Tiaan to talk about CI/CD.
For our CI/CD pipeline, we have 2 sections. In continuous integration, we have implemented Husky pre-commit hooks to run our linter and formatter before code is pushed to the repository. This is to ensure clean and concise code is uploaded. Upon making a pull request to the dev or main branches, our automated workflows are triggered through GitHub Actions to verify the integrity of the code. Then for our continuous deployment section, we have a backend and a frontend. For the backend, when a push is made to the feature/backend/API branch, our backend is automatically deployed to DigitalOcean using a GitHub Actions workflow. Post-deployment, we verify the API's functionality through automated API tests using Assertable. For the front-end, when a pull request is merged into the main branch, Netlify detects the new commit hash and initiates the build and deployment process for our front-end automatically. Then on the next slide, we can see a graph detailing the CI/CD pipeline. And then on the next page, I'll walk you through the DevOps management. For the DevOps management, we have a few sections. For our branching strategy, we have selected to go with Git flow, using the branch's main, dev, and feature branches with occasional use of the hotfix branch. For issue and tracking and management, We linked issues to pull requests, also labeling and assigning issues, and then added issues to our project board to monitor progress. Then for automation, we set up the Husky pre-commit hooks as detailed in the previous few slides, as well as GitHub action workflows. Then for our software assurance, we set up pull request reviews before merging, thus ensuring that the whole team is happy with pull request before it is merged into dev or main branch. And then for our version control, we are tagging our releases before making them. And then in the bottom right-hand corner, you can see a small graph detailing all the sections of our DevOps management. Then I will be handing over to the testing team.
To test the backend or so-called data layer and logic layer of our application, we have decided to use the PyTest framework. Since the entire backend of our application is written in Python, testing with PyTest not only simplified the process because of the familiar syntax and wide variety of libraries available, it also provided us with a code coverage report, ensuring that we meet our testability quality requirement.
PyTest was our framework of choice for front-end unit tests to ensure our components function as expected, thanks to its fast and efficient test execution. Built on Vite, it integrates seamlessly with Vue and is optimized for modern web development, making it a natural decision for us to use.
To test the flow of data between layers, we decided to use ViteTest again for the front end and Postman for the back end. By using Postman, it is easy to simulate how real-world data will react when it is sent through the API, since the API plays a major role in our system. For the non-functional requirements testing, to test our efficiency, we analyzed the performance graphs that was supplied to us by DigitalOcean. And for usability testing, we gathered feedback from usage by either family members or friends, and the application performed adequately in most scenarios.
We utilize Cypress for our end-to-end testing to guarantee that our system functions seamlessly from start to finish. This approach allows us to comprehensively validate the user experience and ensure all components work well together.
As you can see on the current page is a sample report of how the front-end and back-end unit tests performed and the code coverage that it supplied.
So all our documentation is up to date and accessible on our GitHub repository. This includes the software requirement specification, architectural requirements, user manual, testing policy, coding standards, machine learning model specification, and the technical installation manual. You can also alternatively scan on the right-hand side the QR code to instantly view the documentation.
So for project management, we mostly use GitHub. This allowed us to follow an Agile and Scrum process with the usage of sprints and weekly deploys. We also used issue tracking to maintain the overall progress with issue tracking of all team members. And for sprint meetings, we had a daily stand-up meeting from Mondays to Thursdays, and Fridays a big review of everything. Deploys were made on Monday to check the overall progress and to make sure that the app is fully functional on a deployed website. Thank you, everyone.